Good afternoon, time is tight. My name is Geoff Huston. This should be an old topic for most folk, and by now we've thrown facts out of the window and gone for religious zealotry. I would like to haul this back a little bit and kind of give you some facts about, are we really ready for IPv6? It's kind of interesting. It goes back some time. This is 2004, 3901. V6 transport guidelines. And if you look at the text, and I've just highlighted a bit there, it basically says, for God's sake, don't turn off V4. That was the guideline for V6. You know, do what you want in V6, but don't turn off V4, which is kind of, at the time, pragmatic, sensible advice. Someone's proposing in the IETF to reverse that and actually say, here's some V6 guidelines, use it, take it seriously. We recommend that you put V6 absolutely everywhere. And the real question in my mind is this sane advice, or are you demonstrating a fundamental ignorance of how shocking is V6 over actually doing the bits of DNS that matter? Because the problem is V6 really does have a problem with the DNS. You see, the assumption behind this new draft was, we've been using this now for 30 years and we've been getting better. Fragmentation is still a massive problem. All of those header extensions are still a massive problem. Is it as fast? Well, not really. Is it as flexible? Not really. It's only about 5 years more immature than V4, but somehow we've made V4 sing and dance. But V6, not so much. So, 3 questions. You can read faster than I can talk, so let's move on. What is the DNS? What is a resolver? Is 8.8.8.8 a resolver? Of course not. It's a state of mind. It's a whole bunch of machines connected in weird and wonderful ways. Some of them share their caches, some of them don't. Some live an independent existence. Some are merely morons in a larger field. You know, we don't know what a resolver is. So when we talk about do resolvers do something, we've gone into fantasy land straight away. What's a query? Does anyone think they understand what a query is? Good, because neither do I. Because when you look at the way stuff works, I ask my recursive a question, a query, and my recursive resolver goes, Geoff, let me bring the awesome power of the DNS to you and replicate this query over everything that's ever possibly I've talked to, and somehow or other all this stuff will fan out, and by God, someone will answer me. So the queries take on a life of their own. It's not a query, it's a bunch. And so we started looking at this in APNIC, and we seed queries. Now, we do cache busting, it's all unique queries, and we observe and instrument the authoritative server, the sole authoritative server. So all of these queries come to me. Now, I don't know who you are, you're just running an ad, good on you. I can't instrument you. So all of this is done by observations at the server side. First thing, one query, one unique label, I'm going to answer. How many times do I see that question? Well, 54% of the time, once. Yay. 46% of the time, no. 2 or more times. And as you see there on that cumulative plot, 3, 4, 5, 6, 7, 8, 9, 10. The DNS is moronically persistent and astonishingly multiplicative. And so you might think it's a query. Out at the other end, in the sole authoritative server, it's a DDoS attack. And this happens surprisingly often. 30% or more than 3 times. So let's move on to the first question then. You're dual stacked. I'm Akamai, I've got V6 and V4 glue. We heard about that yesterday. This is great. Now, in the web world, we've been told that happy eyeballs is the transition. What you do is you bias your original connection, you start or prefer V6, and you have a little race, and you give V6 a 50 millisecond handicap win. So you launch the DNS. If V6 comes first, you just use it. If V4 comes back first from the DNS, you kind of go, I'll wait for 50 milliseconds. If I get a V6 answer, I'll go V6. Only at the end will you do 4. The whole idea is that in that way, that kind of transition, the more V6 there is, as long as it's well implemented, V4 will disappear of its own accord. Don't need to do anything, because V6 is preferred if it's working well. Does the DNS do this? Because surely this is the way through. Is there happy eyeballs, or are we still addicted to 4? Well, let's look at those 30% of queries that do 3 or more. In fact, let's look at the 54% that do 2 or more queries. 2 or more queries. How many do 6 only? 11%. How many do V4 only? 43%. V4 and V6, they mix it up, 46%. Now, if this was really happy eyeballs, maybe it'd be different. But let's go a little bit further. Because if we sort of put this out, approximately 24% are doing V6 first and then V4. They're kind of doing the happy eyeballs. 20% are doing it the other way, V4 first, and I'll follow up with V6. Then there's V6 only and V4 only, first 2 queries. And if I look at the delays between them, the first 2 queries, you get a kind of odd pattern. Now, some of you will know, because you wrote the code, that said there's a delay between the first and the second queries of exactly 400 milliseconds. Put your hands up. There's someone who said, no, 400's wrong, I'm going to go 380. Put your hand up. And you'll see that echo because it's 380, 720 and so on. And there's another bunch of folk that go 1 second. And you see those peaks. But what amazes me is that right up there in the first 10 milliseconds, there's a whole bunch of folk who go, I'm going to send the second query back to back with the first because, queries are free, more is better. And so there's this astonishing amount of just ganged up queries that happen really quickly, and then the orderly timers happen later. So is this happy eyeballs? No, it's not happy eyeballs. It's nothing like it. Do 6 first, and if you don't get an answer quickly, go to 4. Not happening. Is there a reverse bias to use V4? Well, yes. An amazing bias. So it's not that well supported in terms of the happy eyeballs concept. What about the next thing? Let's go for an experiment and do V6 only, says some zealot out there. And it's kind of, do you really hate your customers? Do you really loathe them to that level of intensity that you're willing to say to 1/3 of your customers, whoops, no DNS today, because we're doing V6? Because 1/3 of customers will not resolve a name. This is out of 51 million over 5 days across the globe, will not resolve a name if the only way to do it is via V6 in the DNS. So a V6 only test is kind of, oops, we are a long, long way from thinking that this stuff is ready. If I compare that, oddly enough, against dual stack, 35% just will not do it. 43% will do V4 only. So there's a certain number of V4 only resolvers that have 6, kind of go, only for emergencies, only really for, I could do it, but I refuse. So it's kind of bizarre, it's not that well out there. So V6 only, you have to be kidding. And now we get on to the big one. The DNS is a whole lot more than name to address. If you look at any of the recent work with Service B, if you look at any of the recent work with DELEG, V6 is now the universal provisioning protocol. One DNS query, one DNS answer, the next packet's data. I know where to go, I know what protocol to use, I know the parameters of the service. So we're using DNS as a, look, just ask and then do data all in one round trip. It's quick, it's efficient, it's the way DNS should be, but you've got to cope with the large answers because we're stuffing all this information from a whole bunch of probing into one answer. So, what did V6 do? It got rid of fragmentation. Didn't do much else, but it got rid of fragmentation. And you'd almost argue that was enough to make life hell. Because who uses fragmentation? Well, even today, despite all the admonitions not to, the DNS uses a lot of fragmentation. And a good place to look at that is the root zone. If you ask the root zone, tell me your DNS key for every single entry in the zone, Poland, 2,193 octets of answer. That's the sort of the top, 20. There's a whole bunch of folk who rely on fragmentation to actually get that DNS key value back to you. So who uses it? A whole bunch of folk all over the world. And in fact, in the root zone, some 300 entries require fragmentation or something else to get that first level answer back at you, because those response sizes really have an awful lot of big answers for the DNS key query. So they rely on fragmentation. Oops. Because anyone who's tried this finds that, trailing fragments are evil, fragmenting is bad, and a lot of security devices go, do not do this. And the issue is with v6, fragmentation on the fly disappeared. You've got to send a message back to the sender going, oh, no, try again, use smaller packets, mismatch. The DNS has not got the time, the patience, or the inclination to muck around. It's UDP, get over it. So in some ways, this is not working. Is this a problem? Let's measure it. We'll go back to the online ad system. We'll send it 32.9 million times, and the answers are big. They're 1,600 octets. They're not that big, but they're big enough to cause fragmentation. Now, I'm using a very standard authoritative server. If you actually put a low EDNS buffer size, I will set the truncation bit and go to TCP. But if you send me, I can handle 4096 octets in my response, then I'll give you it, the whole thing, fragmentation, the lot. And I'm only running v6 because, v6 is more fun. How many folk get the answer? 44%. How many folk don't? 56%. 56%. So if you're saying, we need to move the DNS to v6, how are you going to cope with that brokenness? What do you do to get around that? Well, v4 has to exist forever, which is the default answer from this industry. It really is. Oh, v4 is never going to go away, live with it, we're okay. Which is kind of okay, but it's not where we need to figure out where we're going to be in the long, long run. So, should we try and fix it? Interesting question. What do the RFCs say? Here's one. Blah, 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 blah. For Christ's sake, don't fragment. Do what you want, but you're not allowed to fragment. Which is actually not bad, but then you've got to rely on truncation and TCP. Witness yesterday's conversations, you've got a lot of faith. A lot of faith, because quite frankly, to fix this requires more effort, more money than we're willing to pay. We're not going to do it that way. So, that's not going to work. Add fragmentation on the fly back to v6? Yeah, right, So many folk these days are so full of proposals to change v6, and you sit there and go, after 30 years, aren't you over this? If you really want folk to adopt it, don't change the fundamentals. We're stuck with it. It's never going to change that way. Or just avoid it, just walk around the mess. So go to DNS over TCP by default. I'm sure VeriSign would love it, because the throughput drops by 2/3 straight away. The amount of machinery, and don't forget, like you, I don't pay for my queries to get answered. It's all VeriSign's cost. I'm the beneficiary. For me, queries are free. Do it over TCP, it's free. I'm cool, not going to work. Let's all use TLS, even harder answer. DOH, DO quick, no. Let's change the DNS completely. I like your drugs. It's not reality, but I love your drugs. So you're going to change the application behavior, change the way you sort of do this protocol and do the whole path discovery MTU issue, shift the additional records to some spaceship in the sky. Yeah, right. Not going to happen. So what's kind of left is what we've seen already is actually giving us grief, truncate and fail over, which means we're probably trying to work around these problems of when do you start truncating? DNS Flag Day 2020. God, that was 4 years ago, or 3.5. And the whole idea was you weren't meant to send UDP larger than 1232 to be on the safe side. Who was listening? If I look at the questions that I get, the queries to my authoritative name server, 46% of them are still saying 4096 octets in the answer? No problem, send it down. They're lying. They're completely lying, But you know, almost half the recursives out there going, flag day, didn't listen, don't care, send me big packets, they get dropped, watch me care. 69% of these V6 queries are higher than 1232. So what's the flag day 2020 success rate? 31%. I don't know if that's good or bad. If I had a grade of 31%, that's an F. In fact, it's probably F minus, so that didn't work. So are we ready? Is this shit going to work in 6 only? And the real answer is no. We are simply not ready. And a whole lot of work needs to be done in understanding that the DNS is not going to get smaller. It's not. Somehow, big needs to coexist with what we've got, which means an awful lot more work in trying to make truncation and failover to TCP reliable. And that's not what we have today, which I think I've skated in time. It has been quick, but there is time for questions. So thank you.
We have a question from Alison Menken. I'm going to relay it. How do you determine that 35% of queries that weren't sent in the IPv6 only case?
35% didn't get there. Oh, in this ad system, everyone gets a unique DNS name. And I know the name servers that I give you when I say, here, resolve this URL. So I'm expecting to see that query come back to my DNS. The only sort of record with that name server is a quad A. If I don't see the query, you can't ask. If you can't ask in V6, you're not doing it. So Alison, that's how I get to 35% of the total.
Wes Herdiger, ISI again. Thanks, Geoff. As always, your talks are amazingly brilliant. I'm trying to think of what are the baby steps forward from here. It's what's the first thing that we should do to...
Stop believing resolvers. Authoritative servers should be implementing Flag Day, not leaving it to the recursive resolver to say, I know better than you. Because the authoritative server is kind of go, if I'm going to give you this answer, then I'm going to truncate at 1232. Now, we also need to fix truncation and understand what it means. If I send you back a full answer and I add the truncation bit, do you believe it or throw it away? Do folk use truncated fragments, or does the whole thing get passed away? Is it faster to simply say, the answer's too big, truncate, go away, it's just, you can't do anything with this, come back in TCP? Or do I say, here's a bunch of stuff, there is more, but you may not want it, I'm going to set the truncate bit to say there is more, but if you're happy with what I've got, have a good life and move on. We need to understand some of that stuff and formalise some of the definitions of the semantics of truncation. But at the same time, authoritative servers need to take a much harder line. Now, VeriSign sort of said on their glue records for Akamai, we took a really, really hard line and it killed us. And it's kind of, I'm going to relax it a bit just to get over the fact that truncation and TCP doesn't work too well. But those are the issues I think we're facing right now as sort of the DNS community of how to make this crap work. Because the other way of doing it is you just lose customers because they can't get answers that are big. And that's no good.
Thank you. I hope you were all listening because it's everybody in this room that needs to make those fixes.
That's right. I'm talking to the entire community of folk that can fix this mess. No one else can. It's up to you.
Just a bit of a war story on that, and this is kind of directed at the Flag Day implementers. Maybe a recursive operator, we check, have we deployed the code, the post-Flag Day version of the code? Yes, we have, fantastic. Except, of course, when you apply that new package, you don't replace the config that you have. And so if you have hard-coded in there that the buffer size is 4096, that's what someone might have kept doing for a year or so after the Flag Day. And what would actually be useful is if, along with introducing the new default in the code, that you introduce a new config directive, yeah, I really meant this, so that the existing part of the config, which has been overlooked, is now being overridden.
I don't think authoritative should listen to recursives about that. I honestly think it's now beyond a joke. It's 1232. If you think you can do more, you're lying.
Ben Schwartz, Meta. So I completely agree. Our name servers will not send you more than 1232 bytes. Oh, I just lost my, okay. Will not send you more than 1232 bytes no matter what you ask for. I think basically, I think this analysis is correct, but I'm just not worried about it because the solution is very simple. You just limit your response size, and there's like the distance between us and limiting the response size is much shorter than the distance between us and a v6 only internet. And so like you're not going to get into this state where you've like leaped into the distant future and like implemented teleportation, but you still, you know, haven't gotten the basics.
Second part of this talk, time limiting. What if I truncate no matter what? How many folk actually do TCP, and how many folk are lost lambs going, TCP, too hard? Dwayne's numbers suggest that as high as 20% of his queries were getting lost on the TCP transition. And that is the next measurement, because truncating is great, and it kind of makes the initial part going, I'm talking, we're not losing signal, go to TCP. And the recursive goes, what did you say? And it's that bit that is the next failure point. Some years ago, 7.5% of clients were behind resolvers that did not do TCP. Not even an opening SYN, nothing. And it's kind of, that's awesomely bad. And it's the two problems that have to get fixed. So yay Facebook, Meta, it's the right thing to do. But the next thing is actually back onto the recursives. For Christ's sake, make TCP work. Because if it doesn't, there's no point having a DNS. With that, I'll take a seat. Thank you.
Thank you very much.